All right, welcome. We are going to do a little long division as your warm up, and hopefully, you did this problem already. So, I'm just going to run through in case you made a small mistake somewhere and you're not sure where it was. So, we go ahead and we insert our first polynomial underneath the divisor. There was no missing terms, so we don't have to account for anything there. We throw a little x plus 4, and we ask ourselves, what times x gives us 2x cubed, and it's 2x squared. The numbers underneath that we're going to subtract come from the 2x squared times the x plus 4. So that gives us 2x cubed plus 8x to the, oops, I wrote x to the fourth. So it's really easy to make small mistakes here. Make sure you're checking it. So I'm going to go back. I'm going to change that real quick. And then we are subtracting, and that subtracting, we're subtracting the whole polynomial. So make sure that it is 3x squared minus 8x squared, and the first term cancels out. And we repeat this process once we bring down the negative 13x. And again, we're not concerned about the 4 on the x plus 4. We're just saying x times what gives us negative 5x squared, and that's negative 5x. And then we're just repeating this process. We subtract. We make sure if we get double negatives, it's like we're adding a negative. We're adding a positive, I should say, sorry. And we bring it down, and we repeat. And in this case, when we get done, we don't have a remainder, which is cool. That means it went in perfectly. So to that follow-up question, is x plus 4 a factor? Yes. Factors go into polynomials completely evenly. All right, we are going to do something called synthetic division. It is a process that helps us divide really quickly, and we can use it with linear terms. So here's the setup. We put out the coefficients of our polynomial, and on the outside, we're going to go ahead and put what that factor is equal to. When it's equal to 0, what do we get as x? So the process is that we're going to add vertically. Now the first one, we don't have anything to add, so we're just going to bring this 2 down. And we're going to move across by multiplying by whatever we have on the outside there, which is going to be a negative 4. All right, so now we do 2 times negative 4, which gives us negative 8. Once we have that, we repeat. We add them together, the two numbers that are stacked vertically, and then we get to the next part, next column, by multiplying by negative 4. Every time by negative 4. Now, once we get to the very end, the very last one we get is what we call our remainder. And in this case, there is no remainder. It's a remainder of 0 because it divided in evenly, which we knew when we did the first warm-up problem. I'm just changing some colors. All right, and now to write our final answer, we take the coefficients and we bring down the degree of the original. So since it was originally x to the third, we start with x squared, and we just go down by a degree each time. And that is our final answer. Again, the moving across is multiplying by negative 4. The little pink lines are adding. So here I'm setting this other one up. I am accounting, though, for the fact that there was a missing x term, so we put a 0 there. That's going to be really important. So every time, I'm just going to bring down a number, and then I'm going to multiply by negative 3. Or positive 3, I'm sorry. All my diagonals are multiplying by 3. And my pink lines going downwards, those are just adding the 2. Now you do have to be careful. It is adding every time. I know you might be tempted to say 9 plus 9 is, or 9 minus 9 is 0, but we are adding, and that's going to be a remainder this time. So to write our final answer, since we started with x cubed, we're going to actually start with x squared this time because we divided out that x term. And then we go all the way through, we drop the degrees, and write the remainder. This one here has a ton of missing terms. So we're going to have to account for the fact that we start with a 2, but then there's no x term, x cubed, no x squared, no x term. So there's 3 zeros in those slots. Negative 2 goes on the outside because that's what x plus 2 equal to 0 is. And every time we're just bringing it down, multiplying, adding, multiplying, adding, multiplying, adding. So follow that pattern, and once you get to the very end, that's our remainder. And we drop down the degree. So since we started with x to the fourth, we added these coefficients, x cubed, x squared, x. So the same process can actually evaluate. The remainder is going to be actually the solution that we get here. So I'm going to go ahead. I'm not going to change the sign because we're going to say x is equal to negative 2. And we're going to do the same process, add, multiply, but the remainder is what we get out when we plug in -2. So you can confirm that by plugging in -2 yourself. But that is a fun, cool way to evaluate a polynomial pretty easily. So we have some extra practice problems here. Be careful, there's a missing term on the second one. Make sure that we're going to treat this like x is equal to -2, so that's what goes on the outside. And that just closed my screen. And I guess that ends this video. Feel free to go back. I would recommend pausing and looking at little details to fill in your notes.